All right, so here they're asking us to express the integral as a limit of Riemann sums. Okay, so the general Riemann sum formula is the limit as n goes to infinity of the sum. You have I equal to I, n, and then you have like your like summation formula. So like you have your like this. I don't want to say a function. There's a function, but you basically have your. I'll just say like, yeah, I'll just call it like your summation formula. Different color. Okay, so I know that it looks like that. And I know that the formula that's in there, I'm going to just recopy that again. I know if you this can be broken down to, I'll put it over here, delta x, oops, why did I write that? Delta x times stuff. And this stuff, this other thing, has like this delta x in it. So I'll say stuff, and then I'll put like, not like times, but like in its little argument there, delta x. So you're going to have this value here, and some stuff, this value here, and when you look at it all together, it's like this formula right there. All right, so, and you can think of this stuff portion here as its own little like, as its own little function, right? Maybe it's got like a root or something like that. It'll look very similar to this function right here. But what's in here, like right there, will be different. All right, and that's going to be determined by this guy right here. All right, so we know that we, wait one sec. Yeah, before I continue, the stuff that's in here has to have an I on it. There's an I. Like, not sub I, but like times I. Right there. All right. So, and if you think about like the general formula, real quick, so kind of where this is coming from is what you have up here what you have here is the limit as n approaches infinity of I, and then I equals 1, so from 1 to n of f sub xi times delta x. All right, so it's already kind of backwards from what's here, because when it's written in the like summation formula at the end, they always seem to put the delta x part in the front. But right here is, if you're dealing with rectangles, that's your height, that's your width. And if you notice, there's no sub I here. So that's just straight up delta x right there. But there is an I right here, and that I is related to this I right there. Okay, now let's talk about this xi part, which is right here. All right, so we know that xi x sub I is equal to a plus delta xi. What that means is if you have a curve like this, and let's say you're taking the area from A to B. So you're going from A to B, and you have so many like this is, so A to B is your interval, right? But then you're going from A to B, so we're trying to get the area under the curve from here to here. Then you have these subintervals that are partitioned off as rectangles like this. Now in this example, I'm doing right-hand rectangles. That seems to be the one of choice. So I'm doing these right-hand rectangles like that. Okay, so this right here, let me move this A out of the way, right there. All right. All right, so that's your A. That's your starting value right there. See? So your A. And delta x is just this width, the width of this rectangle. So that's delta x. That's also delta x. That's another delta x. That's another delta x. All right, so to get this right-hand location, to get this value right here, all right, you're going to go with your A, which is your starting value, and you're going to go plus delta x, which is that width. All right, so that means that this value right here is x sub 1. Now, that's x sub 1. So it's A plus delta x. Now, if I want to get x sub 2, what's another delta x away? So I would go x sub 2 equals A plus delta x plus another delta x, which is the same thing as just saying A plus 2 delta x. And that's just adding to widths of the rectangle to get there. But more important than that, bam, we see that this sub 2 kind of corresponds to this sub 2, to that 2 right there. And we notice that this 1 that's right here kind of corresponds to the invisible 1 that's right there. Therefore, these two guys, this guy right here and this guy right there, can be generalized. Both formulas. I could say x sub anything is equal to the first thing plus delta x times whatever that sub anything is. All right, so that's kind of where this comes from. So we know that x sub I, so yeah, so this explains that. All right, so well, we know that x sub I is what goes right here. So our goal is to find out what our x sub I is. So we're going to turn our x sub I into like NI language. So we want to convert x sub I into N language. Or N like, or yeah, N language, but also it's going to, yeah, I guess that's a good way to say it. Or N with an I. So like N, and then you're going to have like an I somewhere. So NI language. All right. And the way we're going to do that is we're going to use this right here as our clue. We're going to use our interval 1 to 3. So we know that because we're going from 1 to 3, right? So if I did a little mini graph again, we know that we're going from, we've got some curve, bam, but they want us to go from 1 to 3. There's our 1, there's our 3. They want the area in there. And it doesn't really matter what the curve looks like. This is just like a basic visual representation. All right, so if we're going from 1 to 3, then we know this is our A, and this is our B. We know that. All right, we also know this formula right here, that x sub I equals A plus delta xi. So x sub I, okay, equals A, well I know that, 1 plus delta x sub I. All right, well, I have something, but I don't have my n yet. I still have my x. I still have x's in there. I want an n instead of a delta x. Okay, so what you want to use is you want to use like the definition of what delta x is. So let me just draw like a little box right here, right there. All right, so delta x equals b minus a over n, number of subintervals. In this case, we're doing infinitely many subintervals, but don't worry about that. So delta x equals our b, which is there, which is 3, minus our a, which is 1. So 3 minus a over n. Aha! Then I can straight up just replace that, or substitute, right? I can substitute that for that. All right, so then x sub I equals 1 plus, I'll just do it in pieces, 3 minus 1 over n, so you can just still see that a and b right there, times I. Let's simplify it. X sub I equals 1 plus, well, 3 minus 1 is 2, 2 over ni, 2 over ni. All right, cool. Well, we just did it. We just converted from xi language to ni language. All right, so that's that. Well, here's our function. This is our function right here. Right, so we know that f of x, we know that f of x is equal to the square root. Let me draw like a line here. Okay, we know that f of x is equal to this, right? 4 plus x squared. Square root of 4, 4 plus x squared. And then we're going to substitute that for our f of xi. F of xi, or let me see something really quick. Yeah, I think the Riemann sum formula, hold on one sec. Yeah, it uses a star by their xi, which doesn't really matter. But there it is, a little star right there. And we'll start right, let's see. So they want a little star by the x right here, right there. And that just means like you're choosing not necessarily a corner as your x value, that you can choose any value for your x value, but it doesn't really matter, or that your rectangles can be any width. And that doesn't really matter also because you're doing infinitely many small widths of your rectangle. So your rectangles are going to be all kind of reduced to like almost zero. Like just they're infinitely many small, like infinitely tiny or infinitely many rectangles under the curve. So it doesn't really matter if they're endpoints on your rectangles or if they're between, because this distance really is going to be reduced to almost nothing. Okay, but anyway, just for notation purposes, you're going to have that, which equals 4 plus xi star squared. I literally just replaced x with xi star. That's all I did. But now, I guess we could say this is our xi star right here, but I won't. Okay, so then we can go ahead and replace this with this right here. There's your xi. So then you can say f of xi star equals 1. I'm just putting this right in. Actually, first I'm doing the root symbol. Root. Then I'm going to go 4. Wait, that's an ugly root symbol. All right, here we go. 1 plus 2 over n. Wait 1 second. Why did I do that? All right, hold on. We're going to do 4 plus big parentheses squared. That's all I did. So where I had parentheses right here, I now have parentheses right here. Okay, and instead of x star or x sub I star, I'm going to replace it with all of this stuff. So it'll be 1 plus 2 over n I, like that. Okay. All right, so that's our f of xi star. All right, so if we go over here to our general formula, which is right up here, I'm going to just copy that down again. Paste it right there. All right. And I'm going to get rid of our, actually I'm just going to kind of spread these out a little bit. Okay, spread this out. Over there. Okay. So for some reason, like I said, they like to put this part second. So let me just put this over here. And I'll put that over there. So when they give it to you in a formula, like the generic formula, they put the fxi first. But then when I see it in like answers as the final presented, like Riemann sum answer, this guy goes first. All right, so delta x. Well, we know delta x. Delta x is this. Just that. It's right here. 3 minus n, 3 minus 1 over n, which is 2 over n. All right, so that goes right here. 2 over n. And that was our delta x. And then down below here, I'll just kind of move that right down there. So you kind of see that. And then I'll put this for color consistency purposes. Oops. One more time. All right. Okay. Now our f of xi star. Got that. There it is. Completely in n language with an I right there. So you're going to go root 4. Going to need a much bigger curly brace. Okay, 4 plus parentheses 1 plus 2 over n I squared. All right, so that's the answer. Super cluttered, so let me just rewrite that. So we have the limit as n goes to infinity, sum of I starting with 1 to n of 2 over n times the quantity, times square root of 4 plus the quantity of 1 plus 2 over n I inside the quantity and squared. And that's it. Oh, and I just checked the answer, and they got the same thing. And they also wrote it, I'm going to write down below how they wrote it. Same thing, but they actually wrote it the way that it looks like in the general formula, so maybe I'm crazy and they don't do that. But I've also seen it written this way. So just they have that there, this here, and this there. Same thing, but that's how it is in the back. Okay, that's it.